Welcome. Today we're going to be talking about the formation of the solar system. First up, between the stars is a vacuum of space. However, it is not a pure vacuum because it is populated with regions of dispersed dust and gases. So in between all of these stars up here is a vast vacuum of space. We've got a little comic over here. Our second part of this is this area also consists of gas and dust. When the gas and dust come together, they begin to spin. This is called a nebula. So in these photos, we have two different nebulas here. This picture on the left was taken in November 5th, 1995 by the Hubble Space Telescope. This is called the Crab Nebula. In the center of this Crab Nebula, where there's this light is kind of originating from, is called the Crab Pulsar, which you can see over here. NASA hypothesizes that this formed 900 years ago. The Crab Pulsar over here is the remnants of the collapsed core of the star. And then this picture right here, we have the stellar nursery. It was taken from a bunch of different infrared pictures of a nebula, and this was discovered in Europe. Next up, we've got the nebular theory. Scientists believe the nebular theory is how our solar system originated. So according to the nebular theory, there was a bunch of gas and dust, and it started rotating, and as it started rotating, you can see here it's condensing in the center, and as it condensed in the center, that's where they hypothesized that the sun formed. So as our rotation speed is increasing, the center of the disk also flattens out like a pancake. So out here we've got like this big ball, and so it starts to spin and it's flattening and then condenses in the middle here, and we've got where they say the sun came from. Here's another view of our nebular hypothesis or nebular theory. We've got all of this gas and dust, and gravity's going to pull it in towards the center. It's going to begin to rotate. Conservation of angular momentum is going to flatten the mass of dust and gas into a flat disk. It's going to make it rotate faster. In the center, everything's going to be pulled to the center, so we get our proto-sun. And then eventually, the spinning forces and gravitational forces will balance out, and so we'll get a star with planets around it. This next part right here got cut off of your notes. I'm going to give you just a second to write it over to the right and that blank space below the bottom of the paper, and then we'll go through the blanks. Alright, so we're going to talk about these things called planetesimals. So in a nebula, as it flattens out, we have all of this junk, ice rock, whatever else, rotating around the central point, the star. As they're rotating around, sometimes these things collide. The little pieces of rock in here collide, and then they stick together. Kind of like if you were to throw those sticky things that you can buy at the grocery store onto the wall, it would clump to it, stick to it. So when these things stick together, they're called planetesimals. The more collisions that we have, so a bunch of collisions and they're all getting stuck together, we're going to have more mass. More collisions is more mass. And the more mass that we get, the greater the gravitational pull is going to become for these things, and then they're going to form planets. So if all of these things right in here are sticking together, then they're going to create their own gravitational field and pull in whatever else is out there in space to stick together to it, and that will eventually lend itself to a planet. So a planetesimal is just basically a baby planet before it is a real planet. These things, again, collide together. The gas and dust and ice and whatever else is out here orbiting around stick together to become a planetesimal. When they get enough mass, they'll get a gravitational pull of their own. So more mass, again, is a greater gravitational pull. You can see this depicted through this little cartoony thing right here. After our planetesimals have been formed and they've created a gravitational field and pulled all of the other stuff into them, we now get planets. In the formation of our solar system, we have two different types of planets. We have inner or terrestrial planets and outer or Jovian planets. So our inner planets, in the inner planets, it was very hot that only metals and silicates could form. So inside the inner planets, Mercury, Venus, Earth, Mars, very, very hot. It's spinning around close to the sun, and the only thing that we can get is silicates and metals. So looking at inside Mercury, inner core, most of the planet's mass, partially molten, silicates, rocks, and then this is going to be metals. Inside Venus, same thing, nickel iron core, which is metals, mantle, silicate rocks, outside silicate rocks. Our next inner planet, Mercury, Venus, Earth, and Mars. Inside Earth, we've got this iron, nickel, metal inner core. Outside on Earth's surface, it's made up mostly of silicates. All of our lava that's coming outside of our volcanoes, mostly silicates. Inside Mars, same thing. Our core is iron, and then our mantle is silicates. There's very little gas that exists in our inner planets because it just evaporates off. It was so hot that the only things that could exist, again, were those molten metals and silicates. Everything else burned up. In the same respect, in our outer planets, gas and ice existed, giving these planets great size. Inside most of these is going to be either like a liquid hydrogen or a liquid nitrogen or a small core. You can see it over here. Metallic hydrogen is the green, so Jupiter and Saturn are both going to have metallic hydrogen, while Neptune and Uranus have a rock core. Because they were further away from the sun and further out in the solar system, and this part of them is pretty large, these planets grew to be really, really massive, but most of their size is just hydrogen and helium. And again, at the end, we just have this formation of planetesimals again. So we start out with our dust and gas, and then it turns into a disk because it's starting to spin and spinning around this central point, the star here. And as it's spinning, the particles inside the dust and gas hit each other and start to clump together, which gives them more mass. This is now called a planetesimal or a baby planet. The baby planet collides with other things that are in this nebula, eventually forming planets, and the planets circle around the star, in our case the sun, and collect everything until they're actual planets. The inner ones closer to the star are going to be mostly metallic, hot, irony, very little atmosphere because it is so hot and the gases evaporate. The further away we get from the star of the solar system or our sun, the bigger the planets are going to become. They're going to be made of ice and gas instead of that molten metal and silicate material.